Greetings, student. This is a recording of one of Garnett's online math lesson classes. You have been granted access to watch this video because you're a paying student and I have seen it fit to provide this recording to you. However, it is important that you know you're not allowed to share this video with persons outside the lessons. This policy is so that my services are kept only to my students. Thank you, and I do hope you enjoy and learn from this video.
So today's session, January 2018, CSEC past paper. We're looking at questions 1 to 3. Like I said before, we'll do as much as we can today. Right? Now, again, I stress on this. When we're doing the past paper session, please try and come have an attempt at the paper. Now, last is a simple computation of fractions, right? Adding and dividing fractions. And usually that is how it goes. So we have, and this is a division, right? And hopefully that makes some of you up. This is a division sign. Right, I'm hoping that didn't put some of you off because I know last time it did. So this is a division sign and 3, 2 thirds plus 1 and 4. Good. Now, one of the things you must recognize here is you have multiple operations going on. Right, and there's no brackets. And once you simple computation, the first rules you should, one of the important rules you should remember is BODMAS, right? BODMAS. You know, BODMAS is the order in which you should do the operations. So you work brackets first, then order. What is order, by the way? You know.
I thought it was of.
Wait,
I thought it was brackets of division, multiplication, addition, subtraction.
Oh wow. I think I thought that too when I was in school before. Oh, I think I thought that too at the point in time. But it's order. Do you know what order is? Can anybody tell me what order is? All right. So if you didn't know this before, order speaks of power. So instead of power, think of order as power. And power is squaring. If you need to square, if you're square rooting, that's also considered a power. And cubing, anything to any raise to any power is order, right? That falls under order. So BODMAS is a general rule of thumb used by mathematicians to solve multiple operation problems. Sorry, what is like that spell? All right, so brackets of multiplication. Forgive my atrocious handwriting. You should know this already though. Addition. And last but not least, subtraction. So you always subtract last, right? You do your subtractions last. So, good. So this is what the rule of thumb we'll use to solve this multiple operation problem, right? So we don't have any brackets, that goes out, no order, no power, division. Next, so the first thing to do is divide. And what I usually do is I just bracket off that. So I know that's what I'm doing first, right? Put the brackets there because you always know the first thing you do is the bracket. So I'm going to do the division of these two, divide these two values, and then I'm going to do the addition, right? So just put that in bracket. So you know you're going to work that first. So division of these are mixed fractions. Anytime you work with fractions, ensure that you're working with a proper or improper fraction. By that, I mean you have some number over some other number like this. You have a proper and improper fraction. It's like this and not with a whole number in front, right? Those are trickier to work with. So we have 5.5. If you can't remember how to convert from mixed fraction to improper fraction, you multiply the denominator by the whole number in front. 2 5s 10, and you add the numerator, which is 1. So 2 5s 10 and 1 11. So 11 over, and you bring back your denominator. Again, if you don't know how to go from improper fraction, from mixed fraction to improper fraction, you take your denominator, multiply it by your whole number. So 3 3 is 9, and add your numerator. 3 3 is 9 plus 2, 11. And you bring back your denominator, of course. So this is the two fractions being converted into improper fractions. Let's do the same for this. It's always easier to work with improper or proper fractions than to work with the mixed fractions, right? It can get confusing. So my advice again would be to convert any mixed fraction into an improper fraction and work from there. So let's convert all of them. So we have 1 and 4/5. 5 times 1 is 5, plus 4, 9, 9 over 5, the improper fraction. So now let's do our division and then do the addition. So 11 over 2 divided by 11 over 3. We know already that to divide two fractions, we just flip the right-hand side and change the sign to multiplication. Right? You can cross multiply 11. I'm multiplying 11 and a dividing 11 will cancel out. Right? So if you don't see that, you can try work out and then do the reduce it to a simpler form. But from right here, 11, I'm multiplying 11 and dividing 11. So an 11 in the numerator, 11 in the denominator. These two will cancel each other out, and we just left with 3 over 2, right? We're still adding the 9 over 5. So we left with 3 over 2 plus 9 over 5, right? Good. So I no need to put the brackets there anymore because we finished with the division. Now, I showed you guys the easiest way to add fractions, whether it's numeric fractions or algebraic fractions. So I'm hoping you guys remember this. So you take the denominator of the first fraction, multiply it by the numerator and the denominator of the second, and then you take the denominator of the second fraction, so 5, multiply by the numerator and the denominator over here. Right? The reason why you do this, and the only reason why you go ahead and do this, is because these two, you can't add or subtract fractions that don't have the same denominator. Right? If you didn't, you should know that. But I know we forget our primary school maths because we are mostly doing algebra now. So don't forget that, right? You can't add this is what I'm saying. Yikes. Writing goes out the window when I try to write. Yeah, right. This is what I'm saying. You can add or subtract fractions with unlike denominators. So this is where you go ahead and do this. I've explained. Right, denominator over here, multiplied with numerator and denominator over there. This move always works because at the end of it, once you finish multiplying these, doing the multiplications, you will always end up with two fractions with the same denominator. So 5 3 is 15, so our new numerator up here is 15, and our new denominator is 2 5 is 10, right? Over here, 2 9 is 18, 2 5 is 10, right? So our new denominator, this is our new fraction. It's the same. Mathematically, these two fractions are the same, but now you have them with the same denominator. So you can go right ahead and add them, right? And you know the way to add fractions with the same denominator is just add the numerators and put back the denominator. In other words, you're just going to add the numerators. So 15 plus 18, and we just bring back the denominator. 15 plus 18 should be 33. And this is our final answer, 33 over 10. Or if you want to convert this to a mixed fraction, 3 and 3/10. Right? I believe you all had this answer. the second part of question A, 1A, this is easy. You could punch this in your calculator, right? You see, easy. This is 3 marks. This is 3 marks, right? So 165 multiplied by 0.38 square. Now, please keep in mind that the square is only on our 0.38, right? The square only governing is 0.38, right? But so I don't think anyone have an issue with this. You have to go ahead and let me know what the answer is. Right, and they say give your answers an exact value. What that means is that they want the exact value you got when you punch it on your calculator, which means yes, you're supposed to actually use a calculator to do it. If you're really wasting time if you actually try to do the multiplication. I know it's fine if you do that outside of the exam. If you want to practice your squaring, your multiplication with decimals and so on, that's fine. But in the exam, use a calculator when you can to save your time, right? So it's 2.825, 23.825, sorry. And this is the answer. I don't think anyone will have an issue with this. But next question deals with, I didn't get to erase this. But the next question deals with the same number, right? So with your answer in AII, in 8 Roman numeral 2, correct to write your answer correct to 2 decimal places. What that means is that behind the decimal point, if you don't, I think I need to say this, but this is the decimal point. Right, good. So behind the decimal point, 2 places behind the decimal point is where we stop, right? So this is one place behind, or 1 DP, 1 decimal place, and this is 2 decimal places, right? So 2 numbers behind the decimal point, 2 places, right? So so 1 decimal place is equivalent to 1 digit behind the decimal point. Right, so 2 would be equivalent to 2 digits, 3 would be equivalent to 3. So just count how many, just count the numbers, right? Good. Now, good. So that's what I had here. Good. Now we're stopping at 2 decimal place, so we stop here. Now every time you're rounding off, so it means you're going to round off, right? Stopping, not writing the exact value, is making an approximation or rounding off. So if you're gonna, you always check the next digit, what the next digit is going to be before you write this. So the answer here is not 23.82. You need to check what the next digit is. Now the rule of thumb, that you should use is you round up if the number is more than, I should use a more than sign, but I'm writing it out in words, is more than 5. If it's 5 or more, sorry, we don't say more than 5, because if it's 5 or more, you round up. That's the rule of thumb. Now I know different persons have different rules, especially with 5, But to make your life simple, round up if the number is 5 or more. So if it's 5, you round up. If it's more than 5, you round up. And if it's less than 5, you round down. And by round down, it means you take the value as it is. So round down doesn't mean you actually decrease anything. It just means you take, but you're actually rounding down, right? It just means you take it as it is. Take the value as it is. So round down if is less than 5. All right, good. So this is the rule of thumb for rounding off decimal places or even significant figures. So 23.882 is the number that is 2 decimal places behind. So we're taking 23.82. This is the value that we're going to use, but you always check to see what the next digit is. Now, if the next digit is 5 or more, you round up. If it's less than 5, you round down. So because the next digit is 6, which is more than 5, we're going to round up, right? We got to round up. And to round up, you just increase the neighbor, the next door neighbor, which is 2, right? You just increase 2 by 3, just increase 2 by 1 value. Because you're rounding up, you just increase the last digit by 1. That's what rounding up means. So when you round up, you're just increasing this value by 1, right? So instead of 23.82, it's 23.83. Now you should all know this already, but I'm going through it nevertheless, right? So again, round up, just increase the last digit there, which is the neighbor, the next door neighbor of where you're stopping. Just round up by 1 value, right? One unit, round up by 1 unit, right? In this case, it's point. Well, this digit is the only thing you're rounding up. So you're always rounding this value up. Don't go ahead and round any other one of these numbers up. Always this guy. So they say 3 significant figures. Now, what I will do is I'll have to take another session and actually go through the rules of significant figures because it seems like some of us forgot. But the rules for significant figures is every non-zero number is significant. Can't write it. I'm not gonna write it. So if you don't, it is in your notes already. I know I went through this in class, but I'm saying it back. If any non-zero number is significant, any trailing zero is significant, but it's only 2. It's 2. Breaking it down to only 2 because 2 is easier to remember than 3 rules. So if any non-zero number is significant, so if it's not 0, then it's significant. If any zero placed in between or after a non-zero number is significant. That's the 2 easiest ways to remember. So every non-zero number is significant, and any zero placed after or in between 2 non-zero numbers is significant. Those 2 rules, you can't go wrong with those 2 rules. Now I'm not going to write it down. It's a bit too much for me to write, but you have those 2 rules, and I remember going through it in class already. So 23.826 is our value. They want us to report it to 3 significant figures. So all you need to do is from left to right count significant figures, count up to 3 and stop. Right, significant figures up to 3 and stop. So 1 significant figure, 2 significant figure. We're going from left to right, always from left to right. So 1 significant figure, 2 significant figure, 3 significant figure. We stop here. Right. Another way they could have asked you to give them the answer in 3 significant figure is if they said 1 decimal place, right? Which means 1 digit behind the decimal point, right? So 3 significant figures. We're stopping here. So it's 23.8. However, remember what you need to do, right? Always check the next value to see if you have to round up or round down. So the next value is 2, right? Which is less than 5, which means we round down. So, and rounding down means you take the value as it is, right? That's what it means to round down. Just take the value as it is. Your 3 significant value as it is. Right? So 1, 2, 3, all 3 of these figures are significant. Right? So to three significant figures, 23.8, and to the nearest whole number. Now we should all know what a whole number is. What whole numbers are. Whole numbers are whole numbers, right? So now they want you to stop at the decimal point. So if you add a decimal point, if it has digits after the decimal point, then it's a decimal, not a whole number, right? So so they want you to stop here, right? So 23 is our whole number, but like I said, you always need to check what the next digit is to know if you have to round up or round down. So 23 is the whole number, but the next digit is 8, right? The next digit is 8, which is more than 5, so we round up, right? Remember, you're rounding the value, right? These two neighbors, you're rounding this value up, right? The last digit in 23, right? So you're rounding that digit up, so instead of 23, it will be 24. That is it concerning, that's it from me concerning this question. Any questions? All right, so part C now, wait. Oh, this is the okay. Part C is asked, it says, Mr. Adams, this is a consumer arithmetic question, right? Part C says Mr. Adams invested $5,000 at the credit union. So he gave them $5,000 and received $5,810 inclusive of simple interest after 3 years. Determine the simple interest earned, right? Now, as soon as you see simple interest, as soon as you see anything that has to do with the word simple interest in any problem, you need to remember this formula, right? This formula will always save you once you know it. So simple interest is always PRT divided by 100, right? PRT divided by 100. Now P is your principal. R is your rate. And T is time, right? Now, let me just put this principal is usually money. The principal P is usually some amount, right? Is it dollars, is money. Rate is usually in percentage, and time is in years, usually in years, right? So remember these units, these are the values that, these are the values that you use. So you notice you have a principal. So when you're looking, you see any simple interest problem, look for the money or the dollar sign, look for the rate, right? The percentage rate, and look for the year, right? So you're looking for time in years. How many years is this going for? Right? They might even tell you months and you have to convert it to years, or days and you have to convert it to years. Sometimes it gets like tricky like that. So you gotta be careful. But those are the units. Now, SI means simple interest. I don't think I need to say this, right? SI simple interest. And this is money. Now, conceptually, if you want to think about it, you should know this in real life too, because when you're dealing with, especially the business students, even anybody, anyone, in literally everyone is going to experience having to deal with some interest, right? Some amount of interest, somewhere or the other. So simple interest. Oh, wow. Okay, I forgot something, but we'll do that later. Yeah, but simple interest deals with interest earned on some amount of money invested, right? If I give you 5,000, I might say, okay, you borrow 5,000 from me. I'm just explaining the concept of simple interest. If, let's say, Rihanna asks me for $5,000, this is the simplest way you can think of it. If Rihanna asks me for 5,000, I sorry, 5,000 is a lot of money. I can lend you it, but when you pay me back, right? She's gonna pay me back. When you pay me back, you give me $5,800. Well, or in this case, Mr. Adam received $5,810, right? That's simple interest. The interest would be common set. The interest would be the $810. You can, and what you can read a problem and already tell what the interest is. So the interest is always the amount of money, the extra money that you earned from somebody borrowing. That's the simplest way I can put simple interest over to you, right? Bottom line is that's how it works. Whether it's with a bank, whether it's your friend, all right? It's always that extra money that they earn that you didn't borrow. You borrow $5,000, right? But because they lend you the 5,000 and probably putting them in some inconvenience, they decide, okay, they gotta give me an extra. How bad you want this 5,000 basically? How bad you want this 5,000? Because you ain't gotta pay me a little extra when you give me it back. That's how simple interest. That's the concept of simple interest, right? And so you'll see it in banks. You see it a lot when you go for when you're borrowing money from the bank. You will see a lot of interest, right? They always take interest. And they say their interest is low, but when you look at it, most banks is really this way they rob you. That's where they rob you. Anybody can tell you that, especially them, especially those very people are greedy. Let me tell you, people are banks are greedy sometimes, and they put some really high interest. But that's the concept of simple interest. So let's look at Mr. Adams' case and get back to the problem. So Mr. Adams invested $5,000 at the credit union. So he's giving them $5,000. They're borrowing $5,000 from him. Think of that. And he received back $5,810, inclusive of simple interest after 3 years. So till after 3 years, he received back this money. So right away, what is the simple interest did Mr. Adam earn? Anyone?
Wait.
$810. You don't even, that's quick maths, it's easy maths, right? It's easy maths. If Mr. Adam invested 5,000 and he get paid and it's a whole 5,800, I mean, there's not a lot of money, but there's a whole 8,500, he get $5,810 he get back, then that's the interest. He earned $810. So it's as simple as that. Right, so the amount he received is the amount, or you can think of it not, you can think of it between me and Rihanna. Rihanna pays me back $5,810 when I only give her $5,000. It's a way of making money. You can actually start a business where you basically lend people money and collect interest. But there are some legal implications. But I'm not a business person, so all right, so this is where it gets tricky. This is where the formula comes in. So conceptually, you can already tell what a simple interest is. We don't need to go to the formula. But they ask now the annual interest rate paid by the credit union. So what happens is that know that when you're dealing with a lot of large sums of money between me and Rihanna, it's just going to be a simple, this is where the formula comes in, right? So between me and Rihanna, it's just $5,000. She could pay me. Yeah, she could pay me the $5,000 in full. Now, if I loan her, I actually lent her $5 million or something like that. It might take her a while to actually pay me $5 million in bulk, but I loan her $5 million. So what happens is that you pay a rate per year or per month. So what happens is SI is equal to PRT divided by 100 is always a form you want to remember anytime you see a simple interest problem. So the interest rate, so we know rate is R, so we're finding R. And so we got to make R the subject of the formula, right? And to do that, okay, let's do a quick change the subject of the formula because we want to find R, not SI. So we got to make R the subject. So 100 is dividing, right over is going to be multiplying. So 100 SI is equal to PRT. Now the reason why I'm telling you to memorize this formula, just memorize this one and you can get all the others by simple rearrangement, transposition. But if you want to sit down and actually memorize all three formulas, the formula for SI, the formula for P, the formula for R, the formula for T, actually don't waste your time and do that. Learn the changes of the formula. You should learn the changes of the formula. So we're looking for R. So R is P is multiplying, T is multiplying, all multiplication over here. So P and T, when they go over, it becomes division. So we end up with R is equal to 100 multiplied by SI, which is simple interest, divided by our P. You guys following so far?
Yes, sir.
Only one person answered. One person answered. All right, so 100 SI divided by PT. Right, good. So now you got to know what these values, what PT, SI, and R are, what I mean. So annual interest rate is R, right? So it's, but I call it rate for short, but it's annual interest rate. And the time is in years. So you see how many years? It's 3 years. So you know the time. The principal. Now what the principal is actually, you can guess it. Tell me, what do you think the principal is? Anyone, what would the principal be for Mr. Adam? What would Miss Adams' principal be?
I would say 810.
Nope, that's the simple interest. That's, remember, simple interest is the
5,000?
the 5,000, right? Don't forget that simple interest is the amount of money, the interest that he made. How much extra did he make off of lending you that money? How much money lent you is the principal, right? So the principal is always the amount of money loan, right? That's the principal. That's the amount of money you lend me. Good, right? And of course, we know that because of how society works in the banks, we always end up at the end of these 3 years, or at the end of the time, we always want to end up with more money than the principal, right? Because we want more money, we want to make something off of this loan, right? So the principal is so instead they call it the principal, but I want you to think of it as the money invested or loan, right? He invested it, so we're looking at his perspective, but it could be paid, could be loan, it could be a loan, it could be invested or loan, right? Good. So that's the principal. And you know, time is in years, so you can easily identify that. And remember, always the simple interest is going to be that the extra. It's not the $5,810. It's the extra that he made, which is $810. So be careful not to put the entire amount, right, including the amount that he loaned. You always need to subtract that to see how much money he made. In business, I think that's profit. You call it profit, right? So you got to think of it, simple interest is the profit. It's not the amount of money they pay back, right? So the profit he's making. So the rate would be equal to 100 multiplied by the simple interest, which we know is $810, divided by the principal, which we said before is the amount of money he invested, which is 5,000, and the time would be 3 years, right? Identify that. So dollars will go to dollars, and what we end up, punch all this in your calculator. Take your time and do it piece by piece in your calculator. If your calculator can't handle all of these numbers line up all at once. So 100 multiplied by 810 divided by 3. 5.4, right? You should get 5.4. And rate is always a percentage, so please attach that percentage sign. Now, if you want to know conceptually where the percentage came from, I'm not going to explain that. Just know the units, right? Just know the units. So this is 5.4, but it's in percentage. This 100 is what's converting these into percentage. You can think of it as 100 years. It's actually year or per year, but it cancels out 100 percentage per year or something like that. But don't do that. Once you remember the units, you'll be fine. All right. If you're calculating rate, then you want to know what this value means. It's 5.4%. And what does that mean? It means that he's paying the interest. He's paying the amount, but the interest rate is 5.4%. So every year he's paying 5.4% of interest. So good. The length of time it now we gotta calculate one more thing. Determine the length of time it will take Mr. Adams' investment to double at the same rate. So it's the same rate. We work with the same rate, but we want to know how much time it would take for his investment to double. So this one is a thinking one, but let's go back to what we know. So we understand what interest means. We understand the concept of simple interest. We know the formula. So the first thing we do is a simple interest problem. So always have the formula right there sitting, waiting to be used, right? So the length, actually you can actually grab a mark just by putting this down. It tells the marker that you know the concept at least, right? Good. So you have the formula, you get a mark. Now, the length of time it will take for Mr. Adams' investment to be doubled at the same rate of interest. So what they're asking you here now, they want to know how long would it take for the money to actually reach $10,000. So he invested. So they don't care about how much they paid. He received $5,810. Fine. But if they kept paying him at the same rate, how long would it take for his money to reach $10,000? So if the money invested is $5,000, I want it to double to $10,000, right? Because 2 times 5,000 is 10,000. What would be the simple interest? Get the formula. We know this. You can get the simple interest by figuring that it's there. We got the rate. It's the same rate as before, which we calculated as 5.4%. And we have the principal. The principal is the amount of money he invested. That has not changed. It's $5,000. We want to calculate the time it will take. So we got to calculate T. So let's make T the subject. So we have a formula for calculating T. Again, 100 is dividing, carried over is going to be multiplying. So 100 multiplied by SI is equal to PRT. And we want to make T the subject. All of this is multiplication. So PR goes to division once carried over the equal sign. So T is equal to 100 SI, which is simple interest divided by the PR, right? The principal and the rate. Good. So the formula here is T is equal to 100 SI divided by PR. Good. What would be the simple interest? Anyone figured it out? Don't forget that. 5,000. It's like $5,000, right? So the interest would be 5,000. Everything else is the same now, right? So 100 multiplied by the 5,000, our new interest, because they want to know how long it will take to double. And the principal is always how much money invested, which is $5,000, right? It's still the $5,000, that didn't change. And the rate, what's the rate? Any one of you?
5.4.
5.4, right? Percent. Good. So 5,000 divided, I'm multiplying 5,000 and a dividing 5,000 will just go out. That's simple math. And so we could just do the 100 divided by 5.4. Let's see what we get.
18.5.
18.5. And what you think the answer is in? What the unit? So 18.5 what? Dog, cat, what?
So years?
Years, because it's time, right? Always remember the units. These things won't tell you anything about the units. Just remember what you're dealing with. If it's time, years. If it's R, it's percentage. If it's principal or the SI, it's dollars, right? Always remember that. So that is simple interest. That is question 1. Question 2 is, this is binary operations. I haven't showed you this before, but let's tackle it nevertheless. So A asterisk, this is an asterisk. This is called an asterisk. So A asterisk B means the square root of A plus 4B. So the simplest way to work these binary operations, so we want to know if the was a value of 1 asterisk 2, right? The simplest way to do this is to map. So if A is first, it's A asterisk B, and this is 1 asterisk 2. So the easiest way is to map it. So A is first, so the 1 is actually A, and B is second, so 2 is actually B, right? So map these two, and also map it in the in what it means. So it's a square root of A is 1, so 1, B is 2, so 1 plus 4B instead of 4. Instead of B, you'll put 2, so 4, 2. So it's a substitution, so 4 times 2. So it's a substitution, and what do you substitute where depends on the position, right? So A asterisk B, A plus 4, square root of A plus 4B, right? So it's a basic substitution. They're substituting for A and substituting for B. That's what this is, right? It's always going to be in the same order. Just to ensure you substitute correctly and do the operations, you should be fine. Now, we're under a square root, so let's work. Let's solve the stuff under the square root. So 1 plus 4 times 2. So 1, 4, 2 is 8. So 1 plus 8. 1 plus 8 is 9. So the square root of 9. And the square root of 9 is
3.
3. Good. Any questions or queries here?
No, sir.
All right. So I didn't take this out. Okay, so good. So the next question is asking whether the operation denoted by the asterisk, which is this guy, whether the operation denoted by the asterisk is commutative or not. I said they want to know if it's commutative and justify your answer. So the answer is, so how do you know when something is commutative or not? What you need to know is what dictates whether something is commutative or not. So okay, I don't know the exact words. So the commutative law says that if we swap around the two values of an operation, the answer remains the same. What does that mean? Is 2 times 3 is 6. And if I swap around 2 and 3 and say 3 times 2, it should be 6. And we know that already. 3 times 2 is 6 and 2 times 3 is 6. So the conclusion you would come here is that multiplication or multiplying, because you can do this to any two numbers and you realize if you swap them, it'll always be the same answer. You can say that multiplication is commutative. Commutative. I don't know why you say commutative. I will keep saying that is a habit, but it's commutative. Right? So multiplication is commutative. Another thing that's commutative is actually addition. So addition is also commutative. So addition, because you can add 3 plus 3 is 6, and oh shucks, I use the same numbers. 6 plus 4 is 10, and 4 plus 6 is still 10. So addition is also commutative. Division is not commutative because 6 divided by 2 is not the same answer as 2 divided by 6. And subtraction is definitely not commutative, right? Commutative, sorry. But so what they want us to do is to tell them whether this asterisk operation is actually commutative or not. So what we got to do now, we know asterisk 1 asterisk 2 is equal to the square root of 9, which is 3. You told me this earlier, is 3. So what they're saying now is if I swap 1 and 1 asterisk 2, 1 and 2, it should be commutative. So 1 asterisk 2 is equal to 3. So what would you do to check if this operation is commutative? Asking you guys.
Then we can go swap a thing.
Swap and check and see if you get. So if I swap 2 asterisk 1, see what answer you get, right? Now, okay, I don't have it on the slide, but remember it's It's a asterisk b is equal to the square root of a plus 4b. So if we do 1 asterisk 1, we know this already, right? So let's swap the 2 and see if we get the same answer. So 2 asterisk 1. So now in this case, 2 is a because a is always the first number, right? So the a and the b hasn't been swapped. This is not what you're swapping. You're swapping values, not the variables. So a is always the first number and b is the second, because that's how it is in your formula. That's how it is going to be when you're working, when you're substituting. So 2 is a, so 2 plus 4, and b is 1, right? So 4 times 1. So in this case, let's go ahead. 4 ones 4 plus 2, the square root of 2, 4 ones 4, so 2 plus 4, and we end up with the square root of 6. And the square root of 6 is, anybody said 3, you want a knuckle. Yeah, I said 3 just now.
Oh.
Wait, who? Where is that? Anybody said 3, they want a knuckle. I know you have one, you said 3.
3.
Who said 3? Who said 3?
Somebody just said 2.
Oh, I said 2? Still a knuckle. Put 6, the square root of 6 in your calculator, you will never get 3 or 2. Now, the reason for that is because you gotta remember what square root is. I know you guys always forget that square root does not mean divide by 2. Square root, I repeat it again, square root does not mean divide by 2. You'll get 2.443. That's the entire decimal, which
Yes,
is not
sir. 2.4494. Well.
good, right? Square root does not mean, I'm writing it, write it down, because like square root does not mean divide by 2, because you would ask person the square root of 10 and they would say 5. No, it doesn't mean divide by 2. Square root never means divide by 2. And I keep saying this, I keep reminding you guys, don't ever do this, because this is catch you off guard. It even catches persons that have been doing maths for a while off guard. It's about 2 point, it's not 4, so it's not 3. All right, so it's about 2.44. And these two answers are not the same. So what can we say, what the answer to this would be? Whether the operation is commutative or not?
It's not commutative.
It's not commutative. Okay, you're saying it better than me. I keep saying computative. Yes, it's not commutative, right? So to check if any operation is commutative, it needs to be the same answer when you swap the two numbers around. So for this asterisk, it's not. So the answer is it's not commutative, not computative. It's not commutative, and our justification, or you could say it's not or none. Non-commutative is actually the correct term to use. Let me actually put that in that. And our justification is right, staring them right here. You get your marks just for doing this, but you can put a small statement that says 1 asterisk 2 is not equal to, this is the mathematician way of doing it, is not equal to 2 asterisk 3. 2 asterisk 1, right? I don't know, I said 3. Next is part B of question 2, which says solve the inequality. Solve the inequality. Think of this as an inequality, so as an equation. So that's not 5. To solve an equation, you need to make the variable the subject of the formula. That's what solving an equation means. And I will again go through this when we look at solving equations. So to solve an equation, it just means make the variable the subject of the formula. So again, think of this as an equation. So instead of carrying 3 over the equal sign, you're carrying 3 over a less than or more than sign. It's still the same. The rules are still the same. The operation is opposite when you carry it over the equal sign. It's the same thing. It's opposite when you carry it over the inequality sign. All the rules are the same, except for one thing. There's one special rule that inequalities have that equations don't have, and that is, you'll see it in a moment. So I'm out of time. That's why I didn't really want to say it. I don't want to give you guys rules right now. So I'm sort of out of time, but we will work. Let me work this out and then leave you. I will give you the one exception. I will indicate it now, but I'll have to give you it officially later. We will go do this topic, not to learn. But carry over 3. 3 is positive, going over now. The operation here, at least in front of the 3 is positive. Going over it become -3, so we end up with minus 2x less than 5 minus 3. To get rid of the 3, you need a -3 on both sides of the equation. So that cancels out, and 5 minus 3. So 5 minus 3, and to get rid of this is multiplying. -2 is being multiplied by x. So -2 times x. The carry over is going to be division. Okay, we can actually solve this. 5 minus 3 is 5 minus 3 is 2. Good, so we finished. Good. Now let's carry over the -2x, the -2. So carrying that over, it's multiplying over here, carried over. It becomes 2 divided by -2, right? 2 divided by -2. So it's multiplying over here, it goes over, it comes division. Or you can take a bit the other way and divide -2 on both sides. This and this. I think this is a better way of doing it instead of, yeah, I'll do it like that. Good. So x, now you notice what I did. The inequality sign, the alligator mouth, is always open to the left, right? And then over here, I opened it, I swapped and opened it to the right. Now I did that on purpose because remember the one special rule that I said that you need to remember? It's actually that. It's actually when you have to swap the sign to the other side. Because equal signs, you don't have to do anything to the equal sign. But with an equality sign, it's facing one side, but there's a special rule that you have to pay attention to, and a lot of students forget it. But you have to pay attention to this, because if you ever end up doing dividing a negative or carrying and multiplying negative over the equal sign and to change it to division or whatever the case might be, like what we did here. If you ever end up having to do something like this, dividing negative on both sides or carrying it, multiplying negative over the equal sign, you need to swap. I will give you the official rule for that, and we will do the topic and go more in depth in it for you guys to have more practice and so on later. But for the sake of this paper, the answer for this question is this, and that is the reason why.